Chapati. So this is Roshni from LearnoHub, the free learning platform where you can learn anytime from anywhere and anything absolutely for free at learnohub.com. So today, in continuation with our previous lessons or previous videos on heat, today we have come up with the fourth part of the video series on heat class 7 science, and in this video what are we going to cover? So we are majorly going to talk about convection and radiation. So we have already covered conduction in the previous video. For those who haven't checked out the previous video, you can check out all the 5 videos of this lesson in the playlist link which is given in the description below. So are we all ready to get started? Let's get started. So it is the transfer of heat by actual motion of matter. So as I was telling, what is this matter? Matter is nothing but the particles which are present in the medium. You remember, the ball is being carried by another person. So this person is nothing but the medium. So the particles of the medium are actually moving from one place to another to transfer the ball from A to B. Now, the way we saw that conduction happens in solids, similarly convection is possible in fluids. Now why in fluids? Because here we want the medium of the particles to actually move from one point to another. So that needs space. Now if you talk about solids, the particles are like very closely fixed. They do not have a lot of intercellular spaces in between them. But in case of liquids, considerably there are more open spaces in between the molecules. So therefore the movement becomes easier, and that is why convection happens in fluids. Now, how exactly do you think convection transfers heat? How heat transfer is caused by convection? Now, the basic concept behind the working of convection is that when air gets heated, air expands. And when air expands, it becomes less dense. Now, what do we mean by that? So, let's say you have this cup of coffee which is placed over fire. Now, the fire is the source of heat. So, this heat, what does it do? It actually heats. Now in this case the vessel is getting heated. Why? That is due to conduction, because vessel is a solid substance which is getting heated by conduction. But when you talk about the fluid, how is the coffee inside this vessel getting heated up? So the coffee is actually getting heated up by the process of convection. Now what happens is, in this case it is a liquid. Now in this case it is air. Like if you have a bonfire lit, what happens? The air immediately above this is more hotter when compared to the air which are there in the sideways. Why is that? That's because the air which is immediately above this, so that gets heated up. So it expands. Now what happens when air expands? So air gets heated up, and heated air expands and it rises up. Now why? So let's understand that. Why do we talk about density? Why is it that when air expands it becomes less dense? So let us suppose this is a scenario where there are 10 people within a room which is this much big. Now if I say that the room size has expanded, I never said that the number of people has increased. I just said that the room size has become bigger, but you have still the same number of people. So you still have 10 people. So when you have 10 people inside a small room, the density is more or less? It is more dense, it is more congested. But when you have the same 10 people inside a big hall, what happens in this case? In this case, it becomes less dense. Now, in a very similar way here also, when the air gets heated up, so air gets heated, so the air expands. Now, when the air expands, it becomes less dense because it is like the room getting expanded, but still the same number of particles remain within the air. So therefore the air becomes less dense. Now since the air has less density, therefore it goes up. So the hot air is going to rise up. So when the hot air rises up, a vacuum is created here. So somebody needs to take that space. So who will take that space? Maybe the air from the sideways. So those air particles will take this place. Again that air will get heated up and again they will move up. Now once they move up, again the sideways air will come, and that's how gradually the air in the surroundings will get heated up. So this is how the concept of convection works. So the heated up air rises up, cooler air comes down. So the cooler air, either from the sides, they come down, again they get heated, and this process continues. And this is how convection works. This is how the liquid inside the vessel gets heated up. So you would, if you would have ever observed, as soon as you keep a pot of water over the oven, it doesn't happen that immediately the entire water gets heated up. So initially the lower layers will heat up, then they will move up, the cooler layer will go down again. So it is like a cycle. So the hot air will go up, again the cooler air will come down, again it will go up, and that's how after some time the entire water will be hot. So this is how convection works. Now let me give you another example to show the presence of convection. Let's say you take a candle and you put your hand just above the flame of the candle. What happens? You feel quite hot. Right? Why do you feel hot? That is due to convection, because you see, you are not in direct contact with the flame, and anyways these are not solids, so there is no conduction happening. But there is a medium between the two, that is air. So there are particles of the air which can actually help in transferring the heat, and that is why you are feeling hot. Now if you place your other hand on the other side, on the side of the flame, I mean not on the top of the flame but on the side of the flame, so will you feel more hot here or less hot here? You will feel less hot. In fact, you will not feel that hot, but you will feel very hot just on top of the candle. That's because the convection happens here, and that is why it is so hot. But here comparatively cooler airs are present, because whichever air is being heated up, it is moving up. So the upper layer of air is maximum hot, and the sideways air, they are cooler. So the cool air is coming here, again getting heated up, moving up. So the process of convection is actually making you feel hot when you place your hand just above the flame when compared to placing it on the sides. So here convection occurs here but not on the sideways. Let us now look at an example of natural convection, the process of convection which takes place in our nature during the day and the night. So first we will discuss the convection process which happens during the daytime. Now during the daytime, if you compare the land and the water bodies could be oceans. So when you compare land and the oceans, now these kind of scenarios can be practically felt in the coastal areas, because in the coastal areas you actually get to have a water body as well as land. So there you can experience these convection effects in a better way. So during the daytime, due to the presence of sun, it happens that the land heats up more quickly when compared to the water body. So this is land and this is the water body. Okay, so land gets heated up more quickly. Now what happens when the land becomes hotter quickly? So the hot air, so when the land is more hotter, so the hot air is present somewhere here, right? So during daytime, this is hot and this is cold quickly. Now what happened is, the hot air here that expands, because the air also near the surface that gets heated up. So as it gets heated up, it expands. When it expands, it becomes less dense and then it moves up. Now when the hot air moves up, what happens? A vacuum gets created here. So who fills that vacuum? That vacuum is filled by the cold air which is coming from the sea. So therefore a bunch of air will be flowing from the cold sea towards the land, and that's how this air will fill up this space. And what is happening to the hot air? It is just going up, and this is coming here, and again it is getting heated and it is moving up. And again when it is moving up, this hot air which in turn is again coming here, it is again going to come back here, and that's how it is like a cycle, and this cycle will continue taking place. But in course of this cycle, what is happening? There is a bunch of cool air which is flowing from water or from the sea towards the land, and this is known as sea breeze. This is called sea breeze. So those living in the coastal areas, if they want to experience the sea breeze, they should construct their houses in such a way that the windows and the doors are facing the ocean, because during the daytime cool air will be flowing from the side of the ocean towards the side of the land. So this cool sea breeze can be experienced in coastal areas during daytime. So in the concept of sea breeze, you see that convection plays the most important role. Now what happens during night? Exactly the opposite thing happens during night. At night, the land gets colder quickly than the sea. So it becomes, now the way land gets heated up quickly, in a similar way land becomes cold also quickly. So when it becomes cold quickly, comparatively the ocean is hot, so therefore the hot air here is moving up, so a vacuum is created here. This vacuum is filled by the cold air coming from the land. So in this case you see that cool air is flowing from the land towards the sea, and this is known as land breeze. So when do you have land breeze? Land breeze happens during night time from land to sea. Now if you look at both the processes, conduction and convection, you see both of them need a medium for heat transfer. You remember the ball example? In both cases, conduction and convection, you need somebody to carry the ball. Right? In the case of convection, you just need one person who can actually move from one place to another to carry the ball, and in case of conduction, you need a lot of people who can just pass on the ball from one to the next. But both need a medium for heat transfer. Whether you think of heating a cup of water, so in order to heat the cup also you need particles of the medium. In order to heat the water also you need some medium, either it is water or air or anything. So you take any of these examples, will you be able to feel the effects of convection had there been no air? If it would have been vacuum, in that case you would have not felt the heat. Similarly, when you cook food, the vessel gets heated up. That is due to conduction, and that is possible due to the presence of a medium. In many scenarios where medium is not available but still we want heat to get transferred, what will happen? There takes place radiation. Now, do you think that any such scenario ever arises where there is no medium but still we want heat to be transferred? Yes, of course. The most common example would be the sun rays reaching the earth. Now, between sun and earth, a lot of vacuum space would be coming. In the space, we really don't know if medium is present everywhere or not. In fact, atmosphere is not present everywhere. But still, the sun rays manage to reach from the sun to the earth. So this happens by radiation. So radiation is that mode of transfer of heat between two bodies separated by a distance, even in vacuum. So even if there is no medium between the two objects, but still heat can be transferred from one object to the other. So now the question is, how is it possible that heat is being transferred in vacuum when there are no particles to carry it? So it is possible in the same way how you throw a ball from A to B. So A and B didn't have to depend on anybody else to carry the ball. So in radiation also no medium is required. So the question is how exactly this radiation gets transmitted. So let us look at the most common example of radiation. So as I said, the radiation from the sun is able to reach the earth, and the distance between the sun and the earth includes a lot of vacuum space as well. So how does this heat transfer happens? So this heat transfer happens in the form of electromagnetic waves, and these are electromagnetic waves which are also called EM waves. So what are electromagnetic waves? These are waves which can propagate in vacuum. So that is one special feature that they have, that these waves, this is how they are represented, and they can travel through vacuum. Now not all waves can travel through vacuum. Vacuum is what? It is empty space which doesn't even contain air. And also these electromagnetic waves travel really fast. So they travel with the speed of light. So speed of light is generally 3 into 10 to the power 8 meter per second. So which is a very high speed. And that is the reason why radiation travels very fast. It is not only a mode of heat transfer in vacuum, but also the fastest mode of heat transfer. Now, These electromagnetic waves are created by vibration of electric charges. They involve both electric and magnetic components, and that is why you see they are marked in blue and red. So blue and red represent the electric and magnetic components respectively. There are different types of electromagnetic radiation which exists, like the visible light, infrared light, X-rays, etc. So they are all different types of electromagnetic radiation. You will learn more about electromagnetic radiation in your class 12, where you will learn electromagnetic waves. But for now, you can just understand that the radiation happens in the form of electromagnetic waves. So as these waves move from one point to another, so the radiation also moves in their form, and because it travels through in the form of electromagnetic waves, that is why they are able to travel through vacuum. That is why they are able to travel with the speed of light, which is very, very high. So the heat transfer from the sun to the earth is a classic example of radiation. Now, as I said, how exactly radiation causes heat transfer? It transfers through electromagnetic waves. The name itself tells that it involves both electric field as well as magnetic field. It propagates through vacuum at the speed of light, as I said, because both of these are the property of the electromagnetic waves, that they can travel through vacuum, they can travel at the speed of light, that is 3 into 10 to the power 8 meter per second. Now that we are talking about radiation, now it is not only that the sun to earth is not the only example of radiation. Now any object, they tend to emit heat energy. Any object by virtue of its temperature. So any object which is heated has a tendency to emit radiation. So all hot bodies radiate heat, and this heat which is being radiated by hot bodies is called thermal radiation. Now this can happen in presence of a medium, this can happen in vacuum, so this can happen anywhere. So in one way I am trying to say that all of us are always radiating heat, because human bodies also have some temperature. Our body also contains some heat, and by virtue of that temperature or by virtue of that heat, we are also radiating some amount of heat. So you would have observed that when you have only one person inside a room, and the same room you have, instead of one, you have 10 persons inside the same room, you start feeling hotter. Why? Because all those persons are radiating some amount of heat. So that room is more heated when there are more number of people. So that shows that all human beings also radiate heat. And this type of heat which gets radiated are called thermal radiation, because this radiation happens by virtue of heat. So you think of a cup of coffee. So if you leave a hot cup of coffee on the table for some time, what happens? The surroundings of the cup of coffee tends to become hotter. Why? Because heat gets radiated from the coffee to the surroundings. Similarly, you think of a candle. So the candle is also radiating heat. So the heat is being radiated to the surroundings. You think of this heater, or you think of your cooking, wherever you are cooking. So when you remain inside the kitchen, you tend to feel more hot, because a lot of heat is being emitted inside the kitchen. In fact, all human beings also radiate heat energy. Now, what happens when this heat or when this radiation fall on some other object? So we are saying that, okay, we radiate heat, but that heat falls on some other object. Now, this radiation falling on any object gets partly reflected. Some part of it gets absorbed, and some part also gets transmitted. Now, what do we mean by these? So, some part gets reflected. So, that means heat falls, this radiation falls on an object and it gets reflected. So, it is not actually taken inside by that object. The second thing is absorbed. That means it falls on an object and it is taken inside. So basically the heat comes inside that object. So that object is going to get hotter. So the temperature of the object will increase. And the third thing that can happen is it can get transmitted. That means the heat will pass through that object and it will get into some other thing. So one thing is it will get reflected. In that case, the temperature of that object will not increase. If it gets absorbed, yes, the temperature will get increased. So now this property, is used in a lot of day-to-day applications. So we will look at some of the examples right now. So, but I hope this concept of thermal radiation is clear. All objects which are hot will radiate heat in the surroundings, and this heat which is radiated when it falls on some other object, so some part of it will get reflected, some part of it will get absorbed, some part will get transmitted. So that is how the concept of radiation works. Now if an object absorbs a large amount of heat, so its temperature will increase and therefore it will tend to become hotter. Now have you ever wondered that why do we prefer to wear light colored clothes during summer? Now the reason behind this also lies in the concept of radiation, which we just discussed just now. So we talked about absorption, right? So anything which absorbs more heat will become more hot. Anything which absorbs less heat will become less hot. That is the simple logic behind all this. So when we talk about light colored clothes, the light colors like white, cream, light pink, all these light colors, they have a tendency to reflect most of the light that fall on them. So as I told you that on any object, whenever radiation falls on any object, there are three options that can happen. Some light might get reflected, some light might get absorbed, some light might get transmitted. If more light is getting reflected, that means less light is being absorbed, right? So with these light colors, most of the light gets reflected. Therefore, less light is absorbed and therefore it becomes less hotter. So therefore, the person feels less hot. Whereas with dark colored clothes like black, they absorb maximum light. So they absorb maximum heat and therefore the body becomes hotter. So with light colors, the body remains cool, and that is why light colors are preferred in summer. Why do we wear woolen clothes in winter? So how does wool help us to feel warm during winter? That's because wool is a poor conductor of heat. So it doesn't allow heat to pass through it. So it traps all the heat. Now our body is continuously emitting heat, as I told you. Now when the body is emitting heat, what happens? This wool being a poor conductor, it doesn't allow that heat to go out of the body. So all the heat gets trapped. And when more heat is being trapped, so we feel warm. And also air is trapped between the wool fibers. So if you look at the wool fibers closely, the wool is knit like this, right? So whatever open spaces you have in between them, in these open spaces are present air, and air is again a poor conductor of heat. So air also doesn't allow heat to go out. So this air as well as wool, all of them together trap a lot of heat, and therefore we feel warm, we feel hot. And therefore woolen clothes are preferred during winters. So no heat flow takes place from the body to surroundings. Now why do you think it is better to use 2 thin blankets than 1 thick blanket during winters? Now again, when we are using multiple blankets, what's happening? Between any 2 blankets, there is 1 layer of air. And air is again a poor conductor, so air will trap heat and therefore it will provide us more warmth. So layer of air is being trapped between 2 blankets, and this will add to insulation. This will add to the warmth of our body, and that's how we will feel more warm. So if it is extreme cold, it is always better to use 2 or 3 blankets rather than using just 1 thick blanket. Now, why are utensils used for cooking blackened at the bottom? So why do you think it happens? If you observe the utensils, you will see that some of them have a copper coating at the bottom, some of them are coated black. That's because these dark colors, they actually absorb a lot of heat. Now when they absorb a lot of heat, the temperature increases fast. Therefore the substances which are present inside, they tend to heat up quickly. So the cooking becomes faster. So black absorbs more radiation, therefore this helps in faster cooking. So see, all these simple things which keep on happening in our day-to-day life, but we do not know the reason behind them. But they are all based on such small concepts.
So Bacha Party, what do you have to say about this video? Did you like the video? If you have a feedback for us, do let us know in the comment section of the video. And if you really liked the video, do not forget to share it with your friends so that they can enjoy learning too. So keep learning, keep enjoying, and I will meet you all very soon with a new video with a new topic. Till then, take care. Bye-bye.